Hello, and thank you for taking some time out of your day and joining us for this discussion. My name is Alex Moss. I'm the CEO and co-founder of Northstar, and we are a technology company focused on risk-based vulnerability management. In today's talk, we'll be focusing on how threat intelligence can help you in your vulnerability remediation efforts, how prediction can help you get ahead of future exploits, and finally, on understanding how the data sources you're using for threat intel can ultimately affect your outcomes. Your speaker today is our head of research, Dr. Dan Corlett.
Thanks, Alex. Let's begin by providing a clear definition of the term prediction as it applies to predicting CVEs that will go on to be exploited in the wild. So at the moment, we're going to assume a basic notion of prediction, which is that we are gaining present knowledge about a future event. The term exploit in the wild is going to refer to a CVE exploitation event that happens in the real world. It involves someone having written or obtained a software exploit, a piece of software code that is then used to take advantage of a vulnerability. This vulnerability is described by the CVE. So we're predicting whether a vulnerability described by a CVE will eventually be leveraged in an exploit in the wild event. But in the attack cycle, you have the following events. Generally, these are identification of the vulnerability. This could be the attacker, a vendor, or another security researcher. You have target identification and reconnaissance. So this is when an attacker is looking for preparing to hit a target. Development of the proof of concept exploit code, weaponization of the exploit, potential commoditization of the exploit, and finally the attack. And so all of these events can leave footprints that we pick up in our threat intelligence and fold into our prediction. In the vulnerability disclosure window, you have the following three states that a CVE can be in. Pre-CVE, this is before an identifier is actually assigned, but the vulnerability has been identified. You have pre-NVD, the CVE number is assigned, but has not been scored by NIST. And then finally, post-NVD, this is when NVD metadata has been provided and that CVE has been scored by NIST. So for us, we require the CVE to be in a post-NVD state. Our main prediction algorithm is an online machine learning based algorithm. Its core models rebuilt daily based on available info. It makes significant use of natural language processing based analysis applied to the unstructured text surrounding the CVE. There's an additional number of numeric-based CVE-related metrics that we derive from dark web analysis, online chatter, malware analysis, vendor reports and data, and some CVE pattern of life analysis. And ultimately, our predictions are packaged up into a REST API. And this is an example of the output. You get a CVE identifier and the date that that CVE was predicted. Our threat intel data set is one of the largest and most significant data sets we consume. We consider it sourced from the world's largest collection platform of its kind, representing the largest data source of this type. We did examine a lot of number of sources, and we decided that this was the best source for us to use for this type of work. So it has billions of daily extractions that are generated within its platform that end up processed and distilled down into actionable pieces of information. While it represents one single source for us, it's essentially many thousands of sources that get curated and end up getting enriched by internal human security experts. So now diving into the three primary numbers we use to characterize the prediction performance. So the first is recall is simply the number of CVEs we correctly predicted relative to the set of exploited in the wild CVEs. That second number, percent reduction, the smaller our prediction set, the larger the percent reduction. So the relationship between these two numbers is that we want recall as large as possible and our prediction set as small as possible. The final and third number is the average number of days we are ahead. So this is the average number of days between a prediction and a verification, and the verification coming in the form of us seeing that CVE labeled exploited in the wild in our threat intel data. So we want this number to be as large as possible. What we see is that CVEs that ended up being predicted earlier ended up being more technically severe, and CVEs that predicted closer to the actual exploitation date, we saw lower scores. So essentially what's happening here is that threat intel is becoming more important as you get closer to the exploitation date, and these CVEs that were scored lower, they may have been missed if it hadn't been for that threat intel that gave the prediction algorithm indication that those were going to be exploited. So hopefully we showed that prediction can reduce and improve vulnerability remediation efforts by focusing attention around the most risky CVEs and providing more time for vulnerability management and patch teams to act.